Hello students, welcome to Swapna physics classes. In this lecture I am going to explain the complete chapter from 10th class, that is reflection of light at curved surfaces. Reflection of light at curved surfaces. This is a one shot lecture on reflection of light at curved surfaces. Here the curved surfaces are spherical mirrors. The curved surfaces are spherical mirrors. When the light ray incidents on the spherical mirrors, it gets reflected. Okay, and in this chapter we are going to learn about these spherical mirrors and the terminology related to them, and then after we are going to draw the ray diagrams, and with the help of these ray diagrams we are going to find out the image formation when the object is placed at different positions, and then after we will derive this mirror formula, and then we will learn about the sign convention, and finally we will derive magnification. Finally we will derive the magnification. Okay, and what are spherical mirrors? Spherical mirrors are of two types. Spherical mirrors. Spherical mirrors are of two types. One is a convex mirror and the other is a concave mirror. Okay, convex mirror. Convex mirror and the other is concave mirror. Concave mirror is will be in the shape of a cave. In the name itself we have cave. Okay, బండ గుర్తు కోసం చెప్తున్నాను నేను మీకు. Okay, concave mirror will be in the shape of a cave. Okay, it will be bulged inward. It will be bulged inward, and on outside, on outward, we will have a aluminium coating or a silver coating. Okay, inside we will have a reflecting surface. This is the reflecting surface. Reflecting surface. Coming to the convex mirror, it is bulged outward. The convex mirror will be bulged outward. This is the reflecting surface for a convex mirror. This will be the reflecting surface. And inside we will have a aluminium coating. We will have a aluminium coating. And coming to the terminology related to the spherical mirrors, okay, the terminology includes the center of curvature. First one is center of curvature. First one is center of curvature. Center of curvature. And then after we will have a pole. What is the center of curvature? If for example I am taking a concave mirror, if you extend this spherical mirror, we will have a sphere. This is the shape of the sphere, right? And for every sphere we will have a center. This center is nothing but the center of curvature of the spherical mirror, okay, which is denoted with C. This will be the center of curvature of the spherical mirror, which is denoted with C. And coming to the pole, pole is the geometrical center. Geometrical center. Geometrical center of the mirror. Geometrical center of the mirror, or the midpoint of the mirror. Midpoint of the mirror. Geometrical center or midpoint, which is denoted with P. Which is denoted with P. And for a concave mirror, this will be the geometrical center, which is denoted with P. This will be the pole of this concave mirror. Okay. And coming to the normal. How to draw a normal for the spherical mirrors? Let's see. If this is a concave mirror, I am always consider a concave mirror only. Finally, I will explain the terminology for convex mirror. Okay. If this is a concave mirror and this is the center of curvature, and this will be the pole for this concave mirror. Okay. And for spherical mirrors, how to find out the normal? Usually for spherical mirrors, we have to draw a tangent, and for this tangent, the perpendicular line drawn from this tangent to the center of the mirror, center of the sphere, is known as the normal. The perpendicular line which joins this tangent and the center of the sphere is known as a normal for spheres. And coming to the plane surface, the line which is perpendicular to this plane surface is known as a normal. Okay, and here the line which joins the center of curvature, the line which joins the center of curvature and a point on the surface of the sphere is the normal of this sphere, of this spherical mirror at this point. Okay, the line which joins the center of curvature and a point on the surface of the spherical mirror is the normal at this point. This will be the normal at this point. Okay, and if you draw one more line from the surface of this mirror, this will be the normal at this point. E point దగ్గర normal into this one. Okay, and at this point this will be the normal, at this point this will be the normal. Okay, the line which joins the center of curvature and the surface of the spherical mirror is known as the normal. Okay, these are the normal lines for different points on the surface of the spherical mirrors. Okay, and coming to the principal axis. Principal axis. What is a principal axis? Principal axis. Okay, for a concave mirror, the line, horizontal line which passes through the pole and the center of curvature, the line which passes through the pole and the center of curvature is known as principal axis. Principal axis. Okay, this is the principal axis for this concave mirror. Okay, and coming to the radius of curvature. What is the radius of curvature? Radius of curvature. Radius of curvature. Okay, the distance between the pole, the distance between the pole and the center of curvature, the distance between the pole and the center of curvature is known as radius of curvature, which is denoted with capital R. Okay, and coming to focus or focus point. Focus or focus point. Focus or focus point, which is denoted with capital F. It is denoted with capital F. Okay, if you consider the rays, the parallel rays to the principal axis, if this is the principal axis, okay, if you consider the incident rays which are parallel to this principal axis, the incident rays which are parallel to this principal axis, these are the incident rays which are parallel to this principal axis. Okay, and these are incidenting this mirror, spherical mirror. After reflection, they will meet at some point on the principal axis. They will meet at some point on a principal axis. This point is known as focus point. This point is known as focus point. Okay, focus point. And coming to focal length. Focal length. What is focal length? It is denoted with small f. It is denoted with small f. For a concave mirror, this is the pole and this is the center of curvature and this is the principal axis. And if this is a focus point, okay, the distance between the pole and the focus point is known as focal length, which is denoted with small f. And you have to remember one thing, the radius of curvature will be always twice of this focal length. The radius of curvature will be always twice of this focal length. Okay, and this is the terminology related to the spherical mirrors. And what about convex mirror? For convex mirrors, this is the convex mirror I am taking, which is coated inward and the reflecting surface will be on outward direction, on outside. Okay, and this will be the pole and this will be the center of curvature and this will be the focus point. Okay, but the reflecting surface is on opposite side of the center of curvature. Concave mirror ki ఏంటి నాన్న సెంటర్ ఆఫ్ కర్వేచర్ ఫోకస్ పాయింట్ వచ్చేసి రిఫ్లెక్టింగ్ సర్ఫేస్ సైడ్ ఉంటుంది. బట్ కమింగ్ టు కాన్వెక్స్ మిర్రర్, ద రిఫ్లెక్టింగ్ సర్ఫేస్ విల్ బి ఆన్ ఆపోజిట్ సైడ్ ఆఫ్ దిస్ ఫోకస్ పాయింట్ అండ్ ది సెంటర్ ఆఫ్ కర్వేచర్. ఓకే, రిమైనింగ్ టర్మినాలజీ అంతా కూడా సేమ్. ఇది పోల్, దిస్ విల్ బి ద ప్రిన్సిపల్ యాక్సిస్ అండ్ ద లెంత్ బిట్వీన్ ద పోల్ అండ్ ది focus point is the focal length, and the length between the center of curvature and the pole is the radius of curvature. Okay, and coming to the ray diagrams. Coming to ray diagrams. Ray diagrams. Ray diagram. Ray diagram for concave mirror. Concave mirrors. So to find out the image, we need few incident rays. But always taking all the rays is not possible. Always considering all the rays is not possible. Why? Because if you consider the different types of rays, that is the ray which is parallel to this principal axis, and if this is the object, okay, and the rays in different direction, the incident rays in different direction. If you consider the incident rays which are passing in different direction and incidenting this spherical mirror, after reflection what happens? They will meet at some point. They will definitely meet at some point, and at this point you will have the image. As the rays are coming from the tip of the object, here you will have the tip of the image for this object. Okay, and the base of this object is about the principal axis of this mirror, right? Therefore the base of the image will be also on the axis of this mirror, right? But always considering all the rays is not possible. For this purpose we are considering only 3 rays. Okay, to find out the image of the object we are considering 3 rays, and out of these 3 rays you can choose any 2 rays. Out of these 3 you can choose any 2 rays. Okay, and what are those 3 rays? Let us see. First of all, I am considering a ray for a concave mirror. If this is the object which is above the principal axis, and this is the center of curvature, and this is the focus point, and this is the pole for this concave mirror. Okay, and I am considering a parallel ray to this principal axis. This is the incident ray which is coming from the tip of the object. Okay, this is the object O. The rays which are incidenting this spherical mirror and are parallel to the principal axis, after reflection what happens? They will pass through the focus point. They will pass through this focus point. Okay, the reflecting ray will pass through the focus point. And one more ray, this is ray R1. Okay, and I am taking one more ray which is passing through the focus point and incidenting the spherical mirror. Okay, this is the object, and I am considering a ray which is passing through the focus of this mirror, which is passing through the focus of the mirror. This is the incident ray, and after reflection it will move parallel to this principal axis. It will move parallel to this principal axis. This is the reflector ray. I am considering this as R2. The ray which is passing through the focus point and incidenting the spherical mirror will always move parallel to this principal axis. I am taking this as R2. Okay, and one more ray is third one for a concave mirror. If this is the position of the object, whenever the ray from the tip of the object passes through the center of curvature, of the mirror and incidenting this spherical mirror, after reflection will move in the same path. After reflection, what happens? This ray will move in the same path but in opposite direction. One more point you have to remember is this ray is passing through the normal. See, the line which joins the center of curvature and the surface of the mirror is known as the normal, right? So here the ray which is passing along the normal of the spherical mirror will always trace the same path but in opposite direction after reflection. Okay, these are the three rays we are going to use for the formation of the image. Formation of the image. Formation of the image when the object is placed at different positions. When the object is placed at different positions, at different positions of a concave mirror. Concave mirror ki object different positions లో ప్లేస్ చేసినప్పుడు మనకి ఇమేజ్ ఎక్కడ ఫామ్ అవుతుంది ఫైండ్ అవుట్ చేస్తాం. ఓకేనా, యూజింగ్ దీస్ త్రీ రేస్ ఓన్లీ. ఓకే, అండ్ ఫస్ట్ ఆఫ్ ఆల్ ఐఎమ్ కన్సిడరింగ్ ద object beyond the center of curvature. If this is a concave mirror, this is a concave mirror and this is the center of curvature and this is the focus point. I'm considering the object. Okay, I'm considering the object beyond the center of curvature and I'm choosing a ray which is R1 from the tip of this object. This ray is passing parallel. This ray is traveling parallel to this principal axis of this mirror. Okay, and after reflection what happens? This ray will travel through the focus point. This ray will travel through the focus point of the mirror and I'm considering one more ray which is passing through this focus. Okay, the ray from the tip of the object will passes through the focus and incidents this spherical mirror. After reflection will move parallel to this principal axis. Okay, see here both the reflecting rays are meeting. At this point both the reflecting rays are meeting, therefore here we will have the tip of the image. This here we will have the tip of the image and the base of the image will be on the principal axis only. Base of the image will be on the principal axis only. Why? Because the rays which are passing through the principal axis will always trace the same path after reflection. Okay, therefore we will have a image of the base. We will have the image of the base on this principal axis only. Okay, here the image is formed in between. Image is formed in between focus and center of curvature. When the object is placed beyond the center of curvature, image is formed in between focus and the center of curvature and this image is inverted. Student invert అయ్యింది. Okay, and it is diminished means the size is decreased. When you compare the size of the image with the size of the object, the size of the image will be small. Okay, object తో కంపేర్ చేస్తే ఇమేజ్ సైజ్ చిన్నగా ఉంటుంది. Okay, and this image formed is a real image. Real image అంటే ఏంటి? The image which is formed on the same side of the object placed. ఆబ్జెక్ట్ ఏ సైడ్ ప్లేస్ చేస్తో అదే సైడ్లో నీకు ఇమేజ్ ఫామ్ అవుతుంది. దాన్ని ఏమంటాం మనం? రియల్ ఇమేజ్ అంటాం. ఓకే, అండ్ now I'm going to find out the formation of the image when the object is placed at the center of curvature. For a concave mirror, I'm taking a concave mirror and this is the center of curvature and this is the object we have. When the object is placed at the center of curvature, where will be the image formed? Let us find out. I'm considering the rays R1 which is parallel to the principal axis. Okay, this is the incident ray from the tip of the object and after reflection it will pass through the focus point and I'm considering one more ray which is passing through this focus. The incident ray from the tip of the object will pass through the focus and incident the spherical mirror at this point. And after reflection, it will move parallel to this principal axis. Okay, this is ray R2. Both these rays are meeting at this point. Therefore, here we will have the tip of the image, and on the axis, principal axis, we will have the base of the image. See, this is the formation of the image. We have the image is inverted. Here, image formed is inverted, and it is of the same size. It is of the same size of the object. It is of the same size of the object. Okay, and it is a real image. It is a real image. Okay, when the object is placed at the center of curvature of the concave mirror, the image formed will be of the same size of the object and is inverted, and it is a real image. Okay, and the next one, I'm considering the image, sorry, I'm considering the object in between focus point and the pole. I'm considering the object in between the focus point and the pole, and this is the center of curvature of a concave mirror. For this object, I'm considering the ray which is parallel to the principal axis, ray R1. Okay, after reflection, what happens? It have to travel through the focus. You have to travel through the focus. Yeah, this is the reflecting ray. Okay, and we have to take one more ray. To obtain the image position, we have to consider one more ray, that is ray R1 or R2. Sorry, ray R2 or R3. But look at here carefully. The image is in between pole and the focus. Ray R2 must have to pass through the focus. The incident ray R2 must have to pass through the focus. Okay, for example, I'm taking the ray R2 for this object. It have to pass through the focus. This will be the incident ray. That means this ray is not incidenting the spherical mirror. It is not incidenting the spherical mirror. It is moving through the focus, and it will go to infinity, right? And if you consider a ray R3, it have to pass through the normal. That means it have to pass through the center of curvature. That means both these rays R2 and R3 are not incidenting the spherical mirrors. Then how to find out the formation of the image for the object which is placed in between pole and the focus? For this purpose, what I'm doing is I'm considering a ray R3. Okay, R3, and I'm just extending this ray in backward so that it will meet at some point. Okay, and the reflecting ray have to trace the same path but in opposite direction, right? That means both these reflecting rays are not meeting at one point. They are moving parallel to each other. Then how to find out the image formed when the object is placed in between pole and the focuses? For this purpose, you just extend these rays. In backward direction of this mirror. Okay, they will meet at some point, and here you will have the image. Here you will have the tip of the image, and the base of the image is on the axis of the mirror. Okay, here if you observe carefully, the image formed will be a visual image. What is a visual image? The image which is formed on the opposite side of the object place. ఇక్కడ ఆబ్జెక్ట్ ప్లేస్ చేసినప్పుడు దానికి ఆపోజిట్ సైడ్ లో మనకి ఇమేజ్ ఏదైతే వస్తుందో దాని విజువల్ ఇమేజ్ అంటాం. ఇట్ ఈస్ ఎ విజువల్ ఇమేజ్ అండ్ ఇట్ ఈస్ అన్ ఎరెక్ట్ ఇమేజ్. ఎరెక్ట్ అంటే స్ట్రైట్ గా ఉంది, ఇన్వర్ట్ అవ్వలేదు. ఇన్వర్ట్ అవ్వకుండా స్ట్రైట్గా ఉంది. ఓకే, ఎరెక్ట్ ఈస్ నథింగ్ బట్ నాన్ ఇన్వర్టెడ్ and it is of large size. Okay, the image is enlarged one. Here we have the enlarged image. When you compare the size of the image with the object, the image size is greater than the size of the object. Okay, these are the three cases. Okay, whenever you move the object from infinity towards this concave mirror, okay, these are the three cases we will find. Okay, and examples for concave mirrors are shaving mirrors and the mirrors used by the dentists. See, the third case, when the object is placed in between pole and the focus. Okay, this case is used in shaving mirrors and dentist, so that the doctor dentist observes the enlarged tooth. Okay, and in shaving mirrors also the third case is used. Before going to explain about the image formation of convex mirrors, I have a question that what happens to the image when the object is placed at the focus point. For a concave mirror, when the object is placed at the focus point, what happens to the image? Where will be the image formed? Okay, try to solve this problem. Okay, I will give you a minute. You just solve this problem. Just pause the video and solve this problem. I will explain this. I'm considering a ray which is parallel to the principal axis. This is ray R1. Okay, after reflection it will pass through the focus point. And I'm considering one more ray which is passing through the center of curvature only. I'm just extending this ray in other side so that it will incident this spherical mirror at some point. But after reflection it will trace the same path but in opposite direction. If you observe carefully, both these rays are parallel to each other. మీరు ఇంకో డైరెక్షన్లో ఈ రేస్ ఎక్స్టెండ్ చేసినా కూడా ఏమవుతుంది, దీస్ రేస్ ఆర్ ప్యారలల్ టు ఈచ్ అదర్ ఓన్లీ. దేర్ ఫోర్ ద ఇమేజ్ విల్ బి ఫార్మ్డ్ ఎట్ ఇన్ఫినిటీ. ఇమేజ్ ఎక్కడ ఫామ్ అవుతుంది, మనకి ఇన్ఫినిటీ దగ్గర ఫామ్ అవుతుంది. ఓకే, వెన్ ఎవర్ యూ కన్సిడర్ ద రేస్ కమ్మింగ్ ఫ్రమ్ ద ఇన్ఫినిటీ, మీరు రేస్ కనుక ఇన్ఫినిటీ నుండి వస్తున్నాయి అనుకుంటే ఆ రేస్ ఎలా ఉంటాయి, నన్ను ప్యారలల్గా ఉంటాయి. ప్యారలల్ టు ఈచ్ అదర్, ద రేస్ విల్ బి ప్యారలల్ టు ఈచ్ అదర్. అంతే కదా, ఇక్కడ కూడా రెండు కూడా ప్యారలల్గా ఉన్నాయి కాబట్టి మనకి ఇమేజ్ ఎక్కడ ఫామ్ అవుతుంది, ఇన్ఫినిటీ దగ్గర ఫామ్ అవుతుంది. అండ్ ఇట్ విల్ బి యాన్ ఎన్లార్జ్డ్ వన్, చాలా పెద్ద సైజులో ఉంటుంది. అండ్ ఇట్ ఈస్ ఎ రియల్ ఇమేజ్, అండ్ ఇట్ ఈస్ an inverted image. Now coming to the convex mirrors. Ray diagram for convex mirrors. Ray diagrams. And coming to the ray diagrams for convex mirror, I'm considering a convex mirror which is bulged outward, and this is the coated surface and this is the reflecting surface for a convex mirror. Okay, and here we will have the focus point and center of curvature. The center of curvature and the focus point will be on the coated side, and on opposite side we will have a reflecting surface. I'm taking an object. Initially the object is at infinity. I'm just moving this object towards the mirror. Okay, and I'm considering a parallel ray from the tip of this object. This ray incidents is spherical mirror, and after reflection this ray will be absorbed. This ray appears to be coming from the focus point. If you extend this reflecting line, reflecting ray on the other side, you will observe that you will feel that this ray is coming from this focus point. The reflecting ray is coming from this focus point. Okay, this is the reflecting ray. And second ray, if you consider a ray from the tip of the object, the incident ray which is moving in the direction of the focus point. The incident ray, if you extend this incident ray, you will feel that the incident ray move in the direction of the focus point. Okay, and after reflection, what happens? It will have to move parallel to the principal axis. Right? This is the incident ray and this is the reflected ray. Now coming to the one more ray, that is the ray which appears to move in the direction of the center of curvature. If this is the object and this is the center of curvature, the ray, whenever you extend on the other side, okay, you will feel that it is moving towards the center of curvature, and therefore the reflecting ray will be in the same path. The reflecting ray will move in the same path as that of the incident ray. Okay, but this reflecting ray will be in opposite direction to this incident ray. Okay, these are the three ray diagrams for the convex mirror. Using these three ray diagrams, we are going to find out the image formation of the image when the object is placed at different positions for a convex mirror. Okay, we will find out the image formation for a convex mirror. I'm considering a object. Initially this object is at infinity, and what I'm doing, I'm just moving the object towards the spherical mirror, which is a convex mirror. Okay, this is a focus, this is the center of curvature, this is the pole. Okay, initially the object is at infinity. For this object, what we have to do, we have to consider the parallel rays only, the rays which are parallel. ఎందుకంటే ఇన్ఫినిటీ నుండి వచ్చే రేస్ మనకి ఎలా అనిపిస్తాయి, ప్యారలల్గా ఉన్నట్టుగా కనిపిస్తాయి. అంతేనా? ఆ డిస్టెన్స్లో ఉన్న ఆబ్జెక్ట్, ఈ ఆబ్జెక్ట్ నుంచి రేస్ వచ్చి ఇన్సిడెంట్ అవుతున్నప్పుడు ఏమవుతుంది, మనకి ప్యారలల్గా కనిపిస్తాయి. ఈ రేస్ అన్నీ కూడా, ఇన్సిడెంట్ రేస్ అన్నీ కూడా మనకి ప్యారలల్గా మూవ్ అవుతున్నట్టు అనిపిస్తాయి. ఓకేనా? నౌ what happens, these rays, these are the reflecting rays. After incidenting, what happens, these rays will be reflected. See, all the rays are moving from each other. They are diverging. Here the rays are diverging. Coming to the concave mirrors, the rays will converge to one point. The rays are converging for concave mirrors, and for convex mirrors the rays are diverging. That means they are moving far away from each other. If you extend these rays on the other side, what happens, you will observe that all these reflecting rays are coming from the focus నుండి వచ్చినట్టుగా కనిపిస్తాయి. ఓకేనా? That means the image is formed at the focus when the object is at infinity. When the object is placed at infinity, the image is formed at focus, and it is highly diminished. అంటే చాలా చిన్నగా ఉంటుంది. ఓకే, highly diminished, and it is a virtual image. ఎందుకు, మనకి ఇటువైపు ఆబ్జెక్ట్ ఉంటే ఆపోజిట్ సైడ్ మనకు వచ్చేసి ఇమేజ్ ఫామ్ అవుతుంది. కాబట్టి దీన్ని ఏమంటాం మనం, వర్చువల్ ఇమేజ్ అంటాం. One more point is, virtual images are not seen on screen. the virtual images will not appear on screen. Will not appear on screen. Screen పైన చూడలేము మనం. Okay, real images అయితే screen పైన చూడగలుగుతాం. Okay, and the image will be erect. Erect అంటే inverted కాదు, non-inverted. Inverted. The image is non-inverted. Okay, and as you move the object from infinity, as you move the object from infinity towards the spherical mirror and is placed in between the pole and infinity. When the object is placed in between the pole and infinity, what happens to the image? Where will be the image formed? Okay, to find out this, I'm considering a ray, the parallel ray to the principal axis. Okay, and after reflection, it have to be appear as it is coming from the focus. When you extend the ray on the other side, you will observe that it appears to be coming from the focus, right? And one more ray I'm considering, that is which is passing through the focus, ray 2. I'm considering one more ray, R2. Okay, if you extend the ray on the other side, you will feel that it is moving towards the focus. Okay, and after reflection, it will move parallel to this principal axis, right? See, if you observe carefully, these two rays will meet at some point. These two rays will meet at some point in between focus and the pole, and the image formed here, the image formed is a virtual image, and it is erect, and it is diminished, and the image will be formed in between focus and the pole. Okay, this is all about the formation of the image when the object is placed at different positions for a convex mirror, right? And our next topic is derivation of formula for curved mirrors. This formula is also known as mirror formula for curved mirrors. Okay, for this purpose, I'm considering a concave mirror. This is a concave mirror which is bulged inward, and we have a coating on outward, aluminum or silver coating on outward. Okay, and this is the focus, and here we have the center of curvature, and this is the pole of this concave mirror. And I'm taking an object AB at this position, and I'm considering a ray R1 which is parallel to this principal axis, and this ray incidents this curved surface at point X, and after incidenting, this ray gets reflected through the focus. I'm taking here the focus point. I'm taking the focus point at this point. Okay, now I'm considering another ray, one more ray, which is passing through the center of curvature. The incident ray is passing through the center of curvature of this mirror. Okay, and after reflection, it will trace out the same path but in opposite direction to this incident ray, and these two reflected rays will meet at this point. Therefore, we have the image at this point, and I'm taking this image as A prime, B prime. Okay, and I'm drawing a perpendicular line from this point X to the principal axis, and it meets this principal axis at point P prime. Now from the figure, from this figure, triangle A prime, B prime, A prime, B prime and C. Triangle, from figure, triangle A prime, B prime, C are similar to triangle AB and C. ABC. ABC. Okay, what are similar triangles? Why we call these as similar triangles? The triangles which are having the corresponding sides of the triangle, the corresponding sides of the triangle are in proportion to each other. If the corresponding sides of the triangle are in proportion to each other, then these type of triangles are known as similar triangles. Similar triangles. Okay, and for example, I have two triangles. These are the two triangles. I am taking this as P, Q, R and this as A, B, C. And the triangle, for this triangle, the side PQ, the ratio of the side PQ to the AB, the side AB of this triangle is equal to the side PR, the ratio of the side PR to the side AC will be equal to QR by BC. QR by BC. Okay, if the ratios of all the three sides of the triangles are equal to each other, then these triangles are said to be, then these sides of the triangles are said to be in proportion to each other, and these type of triangles are known as similar triangles. ఇదంతా కూడా ఒక బాక్స్లో పెట్టేసుకోండి. Okay, now coming to these triangles A prime, B prime, C and triangle ABC. From the figure, I am taking AB by A prime, B prime. AB by A prime, B prime. As these triangles are similar triangles, I am taking this AB by A prime, B prime is equal to AC by A prime, C. AC by A prime, C. This is equation number 1. This is equation number 1. Now from figure, again from figure itself, triangle P prime X F, triangle P prime X F and triangle A prime B prime F. A prime B prime F are similar triangles. Okay, these are also similar triangles. Therefore I am taking the sides P prime X by A prime B prime. A prime B prime are equal to P prime F by A prime F. A prime F. This is equation number 2. And from figure, this P prime X is equal to AB. Why? Because both these rays are parallel to each other. This BX and B prime A are parallel to each other. Therefore, the distance between these two lines at any point will be same. ఎక్కడైనా వీటి మధ్యలో డిస్టెన్స్ ఏముంటుంది, సేమ్ ఉంటుంది కాబట్టి from this figure this P prime X will be equal to AB. P prime X will be equal to AB. Now substitute the value of P prime X. Substitute the value of P prime X in second equation. Okay, therefore we have P prime X is equal to AB by A prime B prime. A prime B prime is equal to P prime F by A prime F. P prime F by A prime F. This is equation number 3. And I am going to use these equations 1 and 3. Okay, here we have AB by A prime B, right? In first equation AB by A prime B we have. In the third equation also we are having AB by A prime B prime on LHS side. Therefore RHS can be equated. Okay, from equations 1 and 3, both left hand side we have AB by A prime B prime. Therefore, we can equate RHS. RHS we have AC by A prime C, which is equal to P prime F by A prime F. A prime F. This is equation number 4. Now I am going to consider the paraxial rays. Now consider the paraxial rays. What are paraxial rays? I will explain. Now consider the rays which are traveling very close to the principal axis. I am considering the rays which are very close to the principal axis. ప్రిన్సిపల్ యాక్సిస్కి చాలా నియర్ బై పాస్ అయ్యే రేస్ ఉంటాయి కదా, అవునా? ప్రిన్సిపల్ యాక్సిస్కి నియర్ బై పాస్ అయ్యే రేస్ ఏవైతే ఉన్నాయో వాటిని కన్సిడర్ చేస్తాం. అండ్ దోస్ రేస్ మస్ట్ బి ప్యారలల్ టు దిస్ ప్రిన్సిపల్ యాక్సిస్. ప్యారలల్గా ఉన్న రేస్ ఏవైతే ఉన్నాయో వాటిని కన్సిడర్ చేస్తాం. అండ్ దీస్ రేస్ ఆర్ నోన్ యాజ్ paraxial rays. The rays which are passing very close to the principal axis and they must be parallel to this principal axis. These are the parallel rays and these are moving very close to this principal axis. These type of rays are known as paraxial rays. These rays are known as paraxial rays. Okay. Now from the figure itself, if you consider the rays which are very close to this principal axis, okay, and if you observe carefully, the rays are meeting at this point. Okay, that means this X point is at this point. Okay, and if you draw a perpendicular line from this X to this principal axis, what happens? This P and P prime will meet each other, right? Therefore what I'm doing, I will draw this diagram once again here itself. Now as these points P prime coincides with each other, therefore we are having this P prime F will be equal to PF. అంతేనా? P prime F దేనికి ఈక్వల్ అవుతుంది? ఇప్పుడు PF కి ఈక్వల్. ఇవి రెండు కోయిన్సైడ్ అవ్వడం వల్ల. Okay, now from equation 4, what is the equation 4 we have? AC by A prime C, which is equal to P prime F by A prime F. This is the equation number 4. In this equation number 4, I am going to substitute P prime F value as PF. Okay, therefore equation number 4 becomes AC by A prime C, which is equal to PF by A prime F. This is equation number 5. Okay, and from figure we have the value of AC. The value of AC will be equal to చూడండి ఇక్కడ AC వాల్యూ, A prime C వాల్యూ, ఓకే, A prime F వాల్యూ ఫైండ్ అవుట్ చేస్తాం. ఇక్కడ మనం AC దేనికి ఈక్వల్ అవుతుందంటే PA minus PC. చూడండి, this is the principal axis we have. This is A, this is P, this is A, and here we have C, right? This AC value will be equal to PA minus PC. అంతేనా? ఈ టోటల్ లెంత్ నుంచి ఈ లెంత్ సబ్స్ట్రాక్ట్ చేస్తే మనకి ఏమొస్తుంది? AC వాల్యూ వస్తుందా? నేను అదే చేశాను ఇక్కడ. డోంట్ గెట్ కన్ఫ్యూజ్. ఓకే, నౌ I want to know the value of A prime C. Here we have A prime C, right? To know this A prime C, I am subtracting PC from A prime P, right? Therefore this A prime C is equal to PC minus PA prime. And the value of A prime F is equal to A prime F. F ఎక్కడ ఉంది నాన్న? ఇక్కడ ఉంది మనకి, అవునా? A prime F తెలియాలంటే మనం ఏం చేయాలి? ఇప్పుడు ఏం చేయాలన్నా ఈ PA prime నుంచి PF ని సబ్స్ట్రాక్ట్ చేద్దాం. ఓకే, PA prime minus PF. Okay, now substitute all these values in equation number 5. Substitute చేస్తే ఏమొస్తుంది మనకి? AC is equal to, what is the value of AC? PA minus PC. PA minus PC by A prime C ఏంటి నాన్న? PC minus PA prime, which will be equal to PF by A prime F ఏంటి నాన్న? PA prime minus PF. Okay, from the figure, PA prime is the image distance, and I'm taking this as V. Okay, and PA, the distance from PA, is the object distance, which is denoted with U, and we left with PF. What is PF? PF is the focal length, which is denoted with small f. Okay, and what is PC? PC is the radius of curvature. It is the radius of curvature denoted with the capital R, right? So you just write the values here. What is PA? PA is equal to U, which is the object distance. Object distance from the pole. And what about PC? PC is the radius of curvature. Radius of curvature, and the value of R is always equal to 2f. మీకు ఆల్రెడీ చెప్పాను కదా, value of R is equal to 2f అని. Okay, now what we left with? PA prime is the image distance from the pole. Image distance from the pole, measured from the pole. Okay, and what we left with? PF. PF is the focal length, which is denoted with the small f. Focal length. Now substitute all these values, right? All these values in this equation. This is equation number 6. I'm considering this as equation number 6. Therefore, what is PA we have? PA is equal to U minus, what is PC? PC is 2f. 2f by PC value is 2f minus, what is PA prime? We have V, which is equal to, what is PF? PF we have small f by, what is PA prime? It is V minus PF is small f. Okay, now you just cross multiply. Here you just do cross multiplication. Therefore you will have U minus 2f into V minus f. This will be equal to f into 2f minus V. 2f minus V. Therefore you just multiply. Now you just multiply this. U into V minus UF minus 2VF minus into minus plus 2F square. Okay, which is equal to 2F square minus V into F, right? Here plus 2F square, 2F square get cancelled. Therefore we left with UV minus UF. If you bring this VF towards left hand side, okay, it will become plus VF. Here we have minus 2VF and plus VF. Therefore it will be minus VF, right? Which is equal to 0. I'm just dividing this equation. This equation number is 7. I'm just dividing the equation number 7. Okay, I'm just dividing the equation number 7 with UVF తో డివైడ్ చేస్తాం. అప్పుడు ఏమవుతుంది? UV by UVF minus UF by UVF minus VF by UVF, which is equal to 0. Okay, now you just cancel the similar terms. You just cancel the similar terms in the numerator and the denominator. Okay, similar terms vf ఇక్కడ ఉంది, ఇక్కడ vf ఉంది. న్యూమరేటర్ లో డినామినేటర్ లో సిమిలర్ టర్మ్స్ ని క్యాన్సిల్ చేస్తే మనకి ఏముంది 1/f minus 1/v minus 1/u, which is equals to 0. Now I am just bringing this 1/v minus 1/u towards left right hand side. Therefore we have 1/f is equal to 1/v plus 1/u. This is the mirror formula. This formula is known as mirror formula. Okay, this formula is known as mirror formula. Okay, in your examinations వాళ్ళు ఏవైనా టూ వాల్యూస్ ఇస్తారు, అంటే u వాల్యూ కావచ్చు, v వాల్యూ కావచ్చు, f వాల్యూ కావచ్చు. ఏవైనా టూ వాల్యూస్ ఇస్తే మనం ఇంకో వాల్యూ ఫైండ్ అవుట్ చేయొచ్చు. అంటే ఇప్పుడు uf ఇచ్చారు అనుకోండి, దే విల్ ఆస్క్ us టు ఫైండ్ అవుట్ v వాల్యూ. vf ఇచ్చి u వాల్యూ ఫైండ్ అవుట్ చేయమంటారు, అండ్ vu ఇచ్చి f వాల్యూ ఫైండ్ అవుట్ చేయమంటారు. యూజింగ్ దిస్ ఫార్ములా we will find out the values of focal length and image distance and the object distance, right? And we have to use this formula. We have to use this formula using sign convention only. Okay, we have to use sign convention. We have to use sign convention while using this formula. Okay, while using this mirror formula, this formula. ఈ ఫార్ములా 1/f equals to 1/u plus 1/v ని సైన్ కన్వెన్షన్ యూజ్ చేసి మాత్రమే యూజ్ చేయాలి. ఓకేనా? అండ్ కమింగ్ టు ద సైన్ కన్వెన్షన్, ఆల్ ద డిస్టెన్సెస్ షుడ్ బి మెజర్డ్ ఫ్రమ్ ది పోల్. అంటే ఏంటి నాన్న, ఇఫ్ వీ హ్యావ్ ఏ concave mirror, okay, this is a concave mirror and this is a pole, and if the image is formed at this point, okay, the distance of this image must be measured from the pole. Okay, the distance must be measured from the pole. And if this is the object, if we place the object at this position, then the distance of this object is also measured from the pole only. Okay, and next point, the distance is measured in the direction of the incident ray to be taken as positive. ఇప్పుడు మనం డిస్టెన్సెస్ మెజర్ చేసేటప్పుడు ఒకవేళ ఇన్సిడెంట్ రే కనుక, if here we have the object and this will be the direction of the incident ray, this is the direction of the incident ray, and we will measure the distance of this object from the pole, right? And I'm taking this as u. ఒకవేళ మనం మెజర్ చేసేటప్పుడు ఏమవుతుంది, ఇన్సిడెంట్ రే డైరెక్షన్ ఈ డైరెక్షన్లో ఉందనుకోండి, అప్పుడు మనం దీన్ని -u తీసుకోవాలి. ఓకే, ఇఫ్ ద డిస్టెన్స్ మెజర్డ్ is in opposite direction to this incident ray, we are measuring the distance from the pole, right? ఈ డైరెక్షన్ లో మెజర్ చేస్తున్నాం, కానీ ఇన్సిడెంట్ రే యొక్క డైరెక్షన్ ఆపోజిట్ డైరెక్షన్ లో ఉంది కాబట్టి మనం దీన్ని నెగిటివ్ సైన్ తీసుకుంటాం. ఓకేనా? ఇఫ్ ద ఇన్సిడెంట్ రే డైరెక్షన్ ఈజ్ ఇన్ ద డైరెక్షన్ ఆఫ్ ద డిస్టెన్స్ మెజర్డ్. ఓకేనా? ఇప్పుడు ఇక్కడ ఉంది ఆబ్జెక్ట్ అనుకుందాం, ఇక్కడ ఆబ్జెక్ట్ ఉంది. ఓకే, దిస్ ఈస్ ద పోల్ అండ్ వీ హ్యావ్ టు మెజర్ ద డిస్టెన్స్ ఆఫ్ దిస్ ఆబ్జెక్ట్ ఫ్రమ్ ది పోల్ ఓన్లీ, రైట్? అయితే అంటే ఏ డైరెక్షన్లో మెజర్ చేస్తున్నాం, మనం ఈ డైరెక్షన్లో మెజర్ చేస్తున్నాం డిస్టెన్స్, అండ్ ద ఇన్సిడెంట్ రే డైరెక్షన్ ఈజ్ ఇన్ దిస్ డైరెక్షన్. ఓకే, బోత్ దీస్ డైరెక్షన్స్ ఆర్ ఆపోజిట్ ఈచ్ అదర్, దేర్ఫోర్ వీ హ్యావ్ టు టేక్ మైనస్ సైన్ ఓన్లీ అగైన్. ఓకేనా? ఒకవేళ సేమ్ డైరెక్షన్లో మెజర్ చేసామనుకోండి, ఫర్ ఎగ్జాంపుల్ హియర్ వీ హ్యావ్ ద ఇమేజ్ ఫార్మ్, ఇక్కడ మనకి ఇమేజ్ ఫార్మ్ అయింది. ఓకే, ఇన్సిడెంట్ రే యొక్క డైరెక్షన్ ఎలా ఉంది, ఈ డైరెక్షన్లో ఉంది. మనం ఈ ఇమేజ్ యొక్క డిస్టెన్స్ ఏ డైరెక్షన్లో మెజర్ చేస్తున్నాయి, ఈ డైరెక్షన్లో మెజర్ చేస్తున్నాం. అంటే ఇవి రెండు కూడా సేమ్ డైరెక్షన్లో ఉన్నాయి కాబట్టి ఇక్కడ మనం +v తీసుకుంటాం. ఓకేనా? సో యూ జస్ట్ గో త్రూ ద స్టేట్మెంట్. The distance measured in the direction of the incident ray to be taken as positive. In the direction of the incident ray, we have to take it as positive, and if it is measured in the opposite direction to the incident ray, therefore we have to take it as negative. We have to take it as negative. Negative sign తీసుకోవాల్సి ఉంటుంది. Okay, and one more point is height of the object. I am considering the height of the object is h0 and height of the image as hi. Okay, if we measure the height of the object and the height of the image upwards from the axis, okay na, if this is the axis, principal axis, this is the principal axis and this is the spherical mirror. Okay, if you measure the height of the object or the height of the image in upward direction, then it is taken as positive. Okay, if you measure in downward direction, then it will be taken as negative. Okay na? And coming to the next topic, magnification. What is magnification? It is our last topic. Okay, magnification. మ్యాగ్నిఫికేషన్ అంటే ఏంటి నాన్న, మనకి ఇమేజ్ ఫామ్ అవుతుంది, రైట్? ఇమేజ్ అయితే ఫామ్ అవుతుంది. ఈ ఇమేజ్ మనం ఆబ్జెక్ట్ సైజ్ కంపేర్ చేసినప్పుడు, వెన్ వి కంపేర్ ది సైజ్ ఆఫ్ దిస్ ఇమేజ్ విత్ ది సైజ్ ఆఫ్ ది ఆబ్జెక్ట్, ఓకే, దెన్ we can find out this size of the image is diminished or enlarged. Size of the image diminished అంటే చిన్నగా ఉందా, diminished ఆర్ ఎన్లార్జ్ అంటే ఆబ్జెక్ట్తో కంపేర్ చేసినప్పుడు అది ఎన్లార్జ్ అయిందా అంటే ఆబ్జెక్ట్ కన్నా పెద్దగా ఉందా చిన్నగా ఉందా అనేది మనం ఫైండ్ అవుట్ చేస్తామో దాన్నే మనం మ్యాగ్నిఫికేషన్ అంటాం. ఓకే, అండ్ ఇట్ ఈస్ గివెన్ యాజ్ ద రేషియో ఆఫ్ size of the object to the size of the image, let's derive the formula. Okay, let's derive the formula for magnification, and it is denoted with a small m. I'm taking a concave mirror, and this is the principal axis of this mirror. This is the pole we have, and here I'm placing the object O prime. Here I'm placing the object O prime. Okay, and this is the focus point we have. I'm considering a parallel ray from the tip of the object to this principal axis. After incidenting, it will get reflected, and the reflected ray will pass to the focus, right? And one more ray is I'm considering a ray which is incidenting this pole. Right? This is the incident ray and this is the reflector ray, and both these rays will meet at this point. Here we will have the image I prime. Okay, and I forgot to explain you one more point, that is law of reflection. What is law of reflection? Law of reflection. I forget to explain this. Actually, I have to explain this in the beginning itself only, but I forgot to explain this. The angle of incident is equal to the angle of reflection. The angle of incidence is equal to angle of reflection. That is, for a plane surface, this will be the normal, right? The perpendicular line which joins this plane surface is the normal. And if this is the incident ray, okay, and this is the reflected ray, the angle made by this incident ray with this normal, okay, the angle made by this incident ray with this normal is taken as I. Okay, I am taking it as I, and the angle made by this reflector ray with the normal I am taking it as R. Okay, the angle of incidence will be equal to angle of reflection for a plane surface. And coming to the curved surfaces also obeys the law of reflection. Okay, for a curved surface, okay, and if this is the center of curvature, and this will be the normal, I'm taking a normal at this point, okay, and I'm considering a parallel ray which is incidenting at this point. After reflection, obviously it passes from the focus, and here this will be the incident angle and this will be the reflected angle. Here also the angle of incidence is equal to angle of reflection. For curved surfaces also the law of reflection is applicable. Okay, now here I'm taking this angle as theta, and this angle is also theta. Why? Because both these are equal. The angle of incident ray is equal to angle of reflector. Okay, I'm taking both these angles as theta. Okay, now from figure triangle POO prime and PI prime. Both these are similar triangles. PI prime and PO prime. Both these triangles are equal. Okay. Both these triangles are similar to each other. Okay. From figure, triangle PO prime and triangle PI prime. Okay. Both these triangles are similar to each other. I'm taking this clearly. ఇక్కడ ఒక ఫిగర్ వేసుకుందాం. This is P, this is O prime, and triangle PI prime. Here we have the image, right? PI prime. Both these triangles are similar to each other. Therefore, from this figure, I prime by O prime, or O prime will be equal to PI by PO. As both these triangles are similar triangles, all the sides of the two triangles will be in proportion to each other, right? Now using sign convention, I'm using sign convention. PO is the object distance. PO is the object distance. I'm taking it as U, but the incident ray direction is opposite to the distance measured. Okay, మనం distance ఈ direction లో measure చేస్తున్నాం, కానీ ఇన్సిడెంట్ యొక్క డైరెక్షన్ ఆపోజిట్ ఉంది కాబట్టి ఇక్కడ మనకి మైనస్ అని వస్తుంది. Okay, and coming to O prime. What is O prime? O prime is the height of the object, and it is measured in upward direction, right? Therefore, I am taking it as H0 plus H0. Okay, and coming to I prime. What is I prime? I prime is the height of the image, and we are measuring this in downward direction from this axis, right? Therefore, I am taking it as minus Hi. Height of the image is Hi. As we are measuring in downward direction, I am taking it as minus sign. Okay, and we left with PI. What is PI? PI is the image distance, right? But we are measuring in this direction, and the incident ray is opposite to this direction. Therefore, I am taking it as minus V. Now substitute all this value in equation number 1. This is equation number 1 we have. In equation 1, substitute all these values. Okay, I prime is minus Hi by O prime is H0. This will be equal to PI is minus V by what is PO? PO is minus U. Okay, therefore this Hi by H0 is equal to plus and get cancelled, minus and get cancelled. I'm bringing this towards right hand side. Okay, minus V by U. This is nothing but magnification. Magnification is equal to the ratio of the height of the image to the height of the object. This will be equal to minus sign of distance of the image from the pole to the distance of the object from the pole. Okay, this is the formula for magnification. Okay, and here I will end our lecture. I hope that I had explained each and every point from this chapter. If you like my video, please click on this like button. And share with maximum number of people, and also click on this subscribe button. Please subscribe to my channel, and also click on the bell icon for more notifications. Okay, bye.